So we're going to take a look at characteristics of polynomial functions. A polynomial function is a function that you'll be very familiar with. It has the form. Now there is a small typo here, and I'll address that right away. This right here should just really be a1x. So a polynomial function has the form y is equal to a sub n, x to the power of n, a n minus 1, x to the power of n minus 1 plus a whole bunch of other things, potentially a1x plus a naught. And it's a function that on the right hand side has a polynomial where the a's, although I understand that it can be a little bit confusing, these a's are just the coefficients of my function. The subscripts n simply are a notation that we use to keep track of which term we're talking about. So a n is the coefficient for x to the power of n. Now a n is known as the leading coefficient. N, the largest exponent, is the degree of the function. Now a naught is the y-intercept, or it's also called the constant of the function. There's one thing that I should comment on, is that the exponents must be whole numbers. That is, the exponents of the variables 0, 1, 2, etc., etc. So no rational exponents, no negative exponents, nothing like that. So although this seems quite ridiculous and long, you're very familiar with these functions. So the three cases that you've studied so far are a constant function. So I'm just going to write down a constant function. So this would be degree 0. And it's degree 0 simply because if you want, we could write y is equal to 3 as y is equal to 3 x to the power 0. That's just the same. The exponent, the largest exponent, is 0. By the way, this is a horizontal line. The next one we can take, if we're going to build this up, y is equal to negative 2x plus 1. This is another polynomial function, and it's a linear function, and it's degree 1 because the exponent, the highest exponent, is 1. So on, so forth, and you're likely able to predict that the next, if we're working up in order of complexity, we would have a degree 2 function, and this is better known as a quadratic. So these are examples of quadratic functions, and if you want, I can make a very simple quadratic function like y is equal to x to the power 6. And if you want, I can continue on by adding terms. And that's still a quadratic function. Now, allow me to write what is not a quadratic function, or sorry, a polynomial function. My mistake. What is not is, for instance, if we have a rational exponent. Y is equal to x to the power of negative 2 is not a polynomial function simply because the degree is a negative number. But more generally, all of our exponents need to be whole numbers. So what we see here is my exponent's negative 2. Now this I would classify as a rational function because we could easily write it as so. Also, this is not a polynomial function, so y is equal to x. Well, that is. But as soon as I add plus the square root of x, well, this is not a polynomial function. Not the one that we're interested in. So just for fun, I'm going to take a look at some polynomial functions. And I'm going to start off with this one. Actually, I'm going to put one more. Y is equal to 3. There it is. It's a straight line, isn't it? It's a horizontal line. Y is equal to 3. This is degree 0. A degree 1 function looks like this. It's a linear function. A degree 2 function would be a parabola. You're quite familiar with a parabola. So, for example, if our leading coefficient here, the coefficient in front of the term with the highest exponent is negative, is going to play an important part. Here it's negative, so it's downward opening. And I'm going to move on to degree 3. So this is what a cubic function looks like. And I'm just going to start adding weird numbers. Oh, whoa. So let's just rewind the clock on that a bit. So y is equal to x to the power 3 looks like that. But the instant that we start putting more terms on, the potential there is to make things more complicated. So now this was the curves it has. Now that's a cubic function. I'm going to go to a degree 4 function. So a degree 4 function can look like this. Or it can look like this. Or it can look like this. Regardless, this is going to get quite complicated, I think. This is a degree 5 function and what it looks like. Now, all of these have some very interesting characteristics that we're going to be looking at. Don't get overwhelmed. We're going to be looking at this from a fairly simplistic view. But it's important to recognize you do have experience with polynomial functions. So I'm just going to